x-intercepts. Think about it like intuitively for just a second here. What are we looking for with an x-intercept? We're looking for a place where the graph does what? It crosses the x-axis, right? What's the, so here's the x-intercepts like that, yeah? That's where y is equal to 0, right? So to find the x-intercepts, we're looking for where x squared minus 8x plus 12 is equal to 0. So we're right back where we started today. To find the places where there are x-intercepts for this quadratic, we have to factor, right? Or complete the square, or use the quadratic formula, like, you know, whatever. I think this one factors though, right? Can you guys tell me? What's that? X minus 6, x minus 2? Hey, it factors, right? So this tells me, so that tells me 6 comma 0 and 2 comma 0 are x-intercepts. All right? So theorem, the vertex, which we call h comma k, all right, is halfway between the roots. So here the roots is another name for the solutions to the quadratic equations, the places where it makes it 0. So like, in other words, h is equal to like root 1 plus root 2 divided by 2. That's the formula for the h component, the x coordinate of the vertex. Where's the y coordinate? Well, that's trickier, but the formula for k, you can just take f and you can evaluate it at h. All right. You can plug the vertex in, plug the where the x is for the vertex in to get the y for the vertex. So like this one, what's the graph look like? Well, let's see here. Let's gather together what we have. We have a y-intercept of 12, right? And we have x-intercepts at 6, 0. So like here. And also there's an x-intercept where? At 2. So it's about here. And I'm telling you that the vertex is halfway between the x-intercepts, all right? So that means that the graph looks something like this. Right. Now, let me tell you another theorem. So this point is 2, this point is 6, and that roughly speaking, folks, is the graph. Another theorem I should share with you is this. If y equals to ax squared plus bx plus c is equal to a times x minus h quantity squared plus k, then h comma k is the vertex of the parabola. And x equals to h is its axis of symmetry. So like continuing to work on this example that I have here, there's two different ways I could find the vertex. The one thing I could do, where's the vertex at? What's halfway between 2 and 6? Where is that? 4, right? So the axis of symmetry here would be at x equals to 4. So like this, it mirrors from one side to the other, right? For example, there's a there's a point which is paired to like the 12. This point here, 0, 12. That is how far? That's 4 from the axis, right? So if I add another 4 to the other side, I get a corresponding point by the symmetry over here of like 8, 12. That's a point on the parabola for what it's worth. All right. So look here then. I've got x squared minus 8x plus 12, right? That's y. And I'm telling you, and maybe you don't quite understand what I'm saying here, is I'm saying by process of inspection, if you reformat the formula for your quadratic in this format, you can read the vertex right off of it. How can we take this and put it into this format? What is that? This is exactly the problem of completing the square. Complete the square on this. I have x minus 4 squared minus 16 plus 12, also known as x minus 4 quantity squared minus 4. From this, I can read by inspection, which is a fancy way of saying just by looking at it. Vertex is where? 4, comma, minus 4. Now the other way to find that minus 4 is to plug 4 into the formula. Right, like here, what would f of 4 be? The formula is what? We take 4, we square it, we minus 8 times 4 plus 12, yeah? F of 4 means this. It means plug 4 into the formula for x, right? What happens when you do this? 16 minus 32 plus 12, also known as what? Minus 4. So that's the other way you could find the y-coordinate for the vertex. Once you know that the x-coordinate is at 4, you can plug 4 into the quadratic and get back out minus 4. I would argue that this completing the square way of finding the vertex is like way, way faster. All right? Let's look at another example, if I can. Sound of the giggling girls in the hallway. We may or may not have time. I don't know. Oh, we got time. By the way, we're in chapter 3 right now. You're like, what? Yeah, I know. Sorry. But hey, it's for a good cause. The reason that I'm skipping around, guys, is simply this. If I followed the order of college algebra that I did like last semester, it puts kind of difficult material in week 1, and I don't want to do that to you. What I'm trying to do is to make it so the course of the flow of the course, I think, is a little bit more logical in my estimation. We do linear, then we go to quadratic, which is second order, right? Then we'll go to polynomials, which are like third or fourth or whatever, right? So we're like going from simple to more complicated to more complicated. Then we'll have test 1. And then after test 1, we'll start looking at what are called rational functions, where those are when you divide one polynomial by another. And then after that, if I remember right, the way I have it formatted, well, anyway, either after or before that, then we'll look at things called radical functions involving radicals. So I've tried to sort of what's the word? Outsource some of the more difficult things to the later part of the course. I think I now have eraser dust in my eye, so it's anybody's guess whether or not I can finish this lecture. So here. Robin? Yeah, sorry. He's decided to be called Robin, and that's fine with me. So like number 33 from section 3.5. Here we're up against f of x equals minus 2x squared minus 12x minus 16. And what we're asked to do here is we're supposed to find the vertex, the axis, the domain, and the range. listen, I'll talk more about domain and range next class. Let's not worry about that just yet. But let's see if we can, this is our last example for today. How do you complete the square on this? What do you do? I don't think we've run up against this yet, have we? So I need to get that minus 2. Factor it out, okay? So minus 2 times x squared plus 6x plus 8. Do you guys agree? And then I will complete the square on what's in the parentheses. So equals minus 2. That's x plus 3 quantity squared. All right? And minus 9 plus 8. And so what I have is I've got minus 2 times parentheses x plus 3 quantity squared minus 1. And I can go, there's a couple different things I can do here. I can do this. Or I could do this. So let me just put it all together. What I have from this expression right here, I have a vertex where minus 3, 2. And from this expression over here, I have minus 4, 0 and minus 2, 0 for x-intercepts. So like here, and let's say here are my x-intercepts. My y-intercept is like up here. And this one has a leading coefficient which is negative. And that, my friends, means that this guy opens down like that. So there you go. Where is the y-intercept? Negative 16, right? It's like down here somewhere. I try not to write on the wall, though. So, do you guys follow what I did? I did the difference of squares factoring trick here. I multiplied it out and used the theorem over there to see the vertex. Now, if you don't get it yet, it's OK. We can talk more about it next time. So, oh, your quiz. Let me not forget to give you your quiz. Everybody, did I hand the attendance sheet out? Everybody got it? Double checked it? Yeah? Es bueno. That's good. Good. So I do need this, like, please do not forget to do the quiz and turn it back to me.